Hello friends, I am Suneeta Phadkule, Professor in Mechanical Engineering, working at JSPM's Jaywantrao Sawant College of Engineering, Hadapsar, Pune. This is our video lecture number 2 for solid mechanics subject for unit number 5. Today we will solve numericals, say 5 numericals we are going to solve on theories of elastic failure. Learning outcome is you will be able to apply suitable theory of elastic failure to predict the failure of mechanical component or mechanical system. Let us see what is a recap. What we have learned in earlier lecture, theories of elastic failure. Okay, and before that one, you have learned what are the principal stresses. So these are the formulae given for principal stresses. Sigma 1 and sigma 2 is equal to sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 bracket square plus tau xy square. And how to find out tau max, that is maximum shear stress? It is plus or minus square root of sigma x minus sigma y bracket square plus 4 tau xy square. Or we can also find out tau max by the formula sigma 1 minus sigma 2 by 2. And we can find out the angle of principal plane by this formula. Tan 2 theta p is equal to 2 tau xy upon sigma x minus sigma y. What is sigma x and sigma y? Sigma x and sigma y are the stresses acting along x direction and y direction, and tau xy is the shear stress acting in xy plane. Okay, so this you have already learned. Then in the earlier lecture we have learned 5 theories of elastic failure. Okay, I also told you how to remember these 5 theories of elastic failure. You should remember in this sequence only so that you can remember it very well. Okay, or you can remember, it's the easiest way to remember. So first 2 theories based on stresses, that is first is maximum principal stress theory, second is maximum shear stress theory. Then middle, this theory number 3, it is based on strain. So maximum principal strain theory. And last 2 theories are based on strain energy. So theory number 4 is maximum strain energy theory, and theory number 5 is maximum distortion energy theory or maximum shear strain energy theory. This is also known as a von Mises theory. Okay. And then we have also seen how to remember these formulae. Okay, so these are written in sequence only. So all these formulae, so for first theory, that is maximum principal stress theory, sigma 1 is equal to sigma permissible. For maximum shear stress theory, sigma 1 minus sigma 2 is equal to sigma permissible. For maximum strain theory, sigma 1 minus mu sigma 2 is equal to sigma permissible. Then maximum strain energy theory, it is sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. And the last one for maximum shear strain energy theory, it is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to sigma permissible square. I also told you in the earlier lecture how to remember these formulae. Okay, so sigma 1 and sigma 2 are principal stresses, mu is Poisson's ratio, and what is sigma permissible? It is the permissible stress which is to be found out from the simple tension test. Okay, so how to find out sigma permissible? It is just say failure stress upon factor of safety. Okay, now let us read the problem statement. For problem number 1, this I have taken from Ratan, and the same problem with values are changed given in Bhavi Katti also, that is strength of material by Bhavi Katti and strength of material by Ratan. A bolt is subjected to an axial pull of 12 kilonewton together with a transverse shear force of 6 kilonewton. So there is a axial force also and shear force also. Determine the diameter of the bolt by using maximum principal stress theory, maximum strain theory, and maximum shear stress theory. Okay, and what else is given? Elastic limit in tension, that is given 300 Newton per mm. Actually it is mm square. Okay, not meter square. factor of safety is equal to 3 and Poisson's ratio is 0.3. Okay, so let us write down the given data. FA, that is axial force, is given as 12 into 10 raised to 3 Newton. Shear force is given 6 into 10 raised to 3 Newton. Then this 300 elastic limit in tension. Okay, we call it as a yield point strength in tension. Okay, because it is for ductile material, we take this as a failure stress. So sigma YT is equal to 300 Newton per mm square. Okay, it is mm actually, not meter. Then mu, Poisson's ratio, is 0.3 and we have to find out diameter of the bolt, that is D. Okay, so let us first find out the stresses. Okay, sigma x. So find out the induced stresses from the given loads. Okay, how to find out tensile stress induced in the bolt? So sigma x is equal to your normal formula which you have used in unit number 1. That is stress is equal to force upon area. So force is FA, that is axial force. It is given 12 into 10 raised to 3. Then area is perpendicular area to the force, that is pi by 4 d square, cross section area of the bolt. Okay, that is pi by 4 d square. So sigma x is equal to 15278.87 upon d square. Here d is unknown and we have to find out the value of d. Okay, so this is the you can say axial stress. Okay, sigma x, it is in x direction we have assumed. Okay, there is no stress, no normal stress in y direction. Okay, so sigma y is 0 here. Then we find out shear stress at the center of the bolt, which is calculated as this. You have learned in shear force diagram and bending moment diagram. Okay, or shear stress, direct shear stresses. In that unit, you have learned how to determine direct shear stress. Okay, so maximum direct shear stress is given by 4/3 average shear stress for circular cross section. Okay, so how to find out average shear stress? Again, by the same formula which we are learning in unit number 1, that is shear force upon cross sectional area on which shear is acting, that is parallel area, parallel to shear force. Okay, so Fs upon pi by 4 d square. This is average shear stress into 4/3 will give you maximum shear stress. Okay, so tau is equal to 4/3 into 6 into 10 raised to 3 upon pi by 4 d square. So tau is equal to 10185.92 upon d square. Okay, so now we know sigma x, we know sigma y, which is 0, then tau. Now we can find out principal stresses. So sigma 1 and sigma 2 is equal to, this is the formula which we have just read in recap, sigma x plus sigma y by 2 plus or minus. Say plus will be for sigma 1, say minus will be for sigma 2. Square root of sigma x minus sigma y by 2 bracket square plus tau xy square. Okay, so here sigma y is 0. Okay, so this formula is reduced to sigma 1 and sigma 2 is equal to sigma x by 2 because sigma y is 0 plus or minus square root of, again here sigma y is 0. So sigma x by 2 bracket square plus tau square. Here tau xy we call it as a tau. Okay, so put these values. Okay, we have found out sigma 1, sigma 2, we found out sigma x and tau. Okay, so when we put this value, okay, we get, this is simply addition. Okay, and this is we remove, it is a we add it and then we remove the square this square root. So we get sigma 1 and sigma 2 is equal to this plus or minus this. Okay, so by adding it we get sigma 1, okay, 20371.83 upon d square, and by subtracting we get sigma 2. Okay, then how to find out tau max? Sigma 1 minus sigma 2 by 2. Okay, so sigma 1 is this one, sigma 2 is minus, so minus minus will become plus. Okay, so this is tau max. Tau max is equal to this one. Okay, now calculating permissible stress in simple tension test from the given yield point strength and given factor of safety. Okay, so what is given? Sigma yt is given 300 Newton per mm square. Okay, and factor of safety is given 3. Okay, so sigma permissible is equal to 300 by 3, that is 100 Newton per mm square. Actually here also it is everywhere it is mm square and not meter square. Then now we see one by one theory. Okay, this much portion was common to all three theories. Now let us see the first theory. From maximum principal stress theory, what is your equation? Sigma 1 should be less than or equal to sigma permissible. So in the limit it is sigma 1 is equal to sigma permissible. Okay, what's the value of sigma 1? We have found out here. This is your sigma 1. Okay, so sigma 1 is equal to sigma permissible. So this is sigma 1, this is sigma permissible. Okay, from this equation we find out diameter. So what is the diameter from this theory, principal stress theory? 14.27 mm. Okay, now let us go to the second theory, that is maximum principal strength theory. So what's the equation for this? This is theory number 3. Okay, sigma 1 minus mu sigma 2 is equal to sigma permissible. Okay, sigma 1 we have found out this one, mu is given 0.3, sigma 2 we have found out which is minus, so minus minus will become plus here, is equal to 100, that is sigma permissible. Okay, so adding it we get this equation, and from this equation we find out D, that is D is equal to 14.80 mm. Okay, then let us see the third theory, that is from maximum shear stress theory. In our sequence this is theory number 2. So what is the equation for this theory? Sigma 1 minus sigma 2 is equal to sigma permissible. Okay, sigma 1 we have found out, sigma 2 we have found out. So sigma 1 minus minus plus sigma 2 is equal to sigma permissible. So from this diameter is getting 15.95 mm. Okay, now see all three we have calculated diameter by using all three theories which are given to us. So now there are three different values. This is 15.95, then 14.80 and 14.27. Okay, now which value we should consider? Okay, so from above three theories we have to select value of minimum diameter. Okay, so where we get minimum diameter? By using maximum principal stress theory, which is 14.27. Okay, now why this is, why minimum only? Okay, see, if we use minimum diameter, okay, then what stress we will get? Force upon area, area will be minimum, then your induced stress will be maximum. This is your assumption. Okay, if we use maximum diameter here 15.95, so area will be maximum and induced stress will be minimum. Actually we don't know because of which theory actually your part is going to fail. These are all assumptions. Okay, so what is safer? To use the maximum stress. Okay, because minimum diameter will give you maximum stress. Okay, so maximum stress will be always safe, because if at all the second theory will be applicable, if your shaft or if your part is going to fail with that theory, then it will create the minimum stress, no? So maximum stress will be always safer. That's why you have to select minimum diameter. Okay, if you don't understand this one, because I cannot write down here, you please dial me, I will explain you. Okay, then we'll go to problem number 2. This I have taken from theory strength of material by Ratan. Okay, so what's the problem statement? Principal stresses at a point in an elastic material are 100 MPa tensile and 25 MPa compressive. MPa means megapascal, that is Newton per mm square. Okay, 1 megapascal is 1 Newton per mm square. Determine the factor of safety against failure based on various theories. So here we have to use all 5 theories. The elastic limit in simple tension is 220 megapascal, that is sigma YT, and Poisson's ratio is 0.3. Okay, so what are given? Sigma 1, see here, why sigma 1? Principal stresses are directly given. Okay, so sigma 1 is 100 Newton per sorry, here also mm square, sorry. So here 100 Newton per mm square, sigma 2 is minus 25 Newton per mm square, then sigma YT 220 Newton per mm square, please make this correction. This is mm square, not meter square. By mistake, it is a mistake from me that by mistake I have typed meter square. Then mu is 0.3 and we have to find out how much should be the factor of safety. Okay. So let us go to first theory. According to maximum principal stress theory, what is our equation? Sigma 1 is equal to sigma permissible. Okay. So what is the statement of this theory? Failure takes place when the maximum principal stress in the complex stress system reaches the value of maximum stress at the elastic limit in the simple tension test. Okay. So mathematically sigma 1 is equal to sigma permissible. How to find out sigma 1? How to find out sigma permissible? It is yield point strain in tension upon factor of safety. Okay. So sigma 1 is equal to sigma YT upon Fs. Okay. We have to find out Fs. So Fs is equal to sigma YT upon sigma 1. Sigma YT is given 220 Newton per mm square. Sigma 1 is also given 100 Newton per mm square. So we got factor of safety, that is 2.2 from the first theory. Okay. Now let us go to second theory. That is according to maximum shear stress theory. What is your equation? Sigma 1 minus sigma 2 is equal to sigma permissible. Okay. So what is the statement of this theory? Failure takes place when the maximum shear stress in the complex stress system reaches the value of maximum shear stress at the elastic limit in simple tension test. Okay. So that means tau max is equal to tau permissible. How to find out tau max in complex system? Sigma 1 minus sigma 2 by 2 is equal to, how to find out tau permissible? It is sigma permissible by 2. See, this is the relation. This is true for all material. Usually, permissible shear stress is 50% of permissible tensile strength. Okay. So that's why tau permissible is sigma permissible by 2. Okay. So sigma 1 is given 100 Newton per mm square. Sigma 2 is minus 25 Newton per mm square. Then sigma permissible is what? Sigma YT upon Fs upon 2. Okay. So from this equation, we found out Fs, that is factor of safety is 1.76. Okay. Now let us go to third theory. According to maximum principal strain theory, what is the equation? Sigma 1 minus mu sigma 2 is equal to sigma permissible. Okay. So according to this theory, failure takes place when maximum principal strain in the complex stress system reaches the value of maximum strain at the elastic limit in the simple tension test. Okay. So how to find out maximum strain in complex system? Sigma 1 minus mu sigma 2 upon E. Okay. And how to find out permissible strain? Epsilon permissible is equal to sigma permissible upon E. What is sigma permissible? Sigma YT upon Fs. Okay, that is failure stress upon factor of safety. Okay, so equating these two, this is sigma YT upon E into Fs is equal to sigma 1 minus mu sigma 2 upon E. E will be cancelled out. Okay, sigma YT is given to you, that is 220. Okay, then sigma 1 is given to you 100, mu is 0.3, sigma 2 is 25. Okay, minus will become plus here. Okay, from this equation, we find out factor of safety, that is 2.04. Okay, now let us go to theory number 4, that is maximum strain energy theory. So what's the equation? Sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. So what's the statement of this theory? According to this theory, failure takes place when the maximum strain energy per unit volume in the complex stress system reaches the value of strain energy per unit volume at the elastic limit in simple tension test. Okay, so this is your equation. Now what is sigma permissible? It is sigma YT upon Fs, failure stress upon factor of safety. Okay, now put all the values. Sigma 1 is 100, sigma 2 is minus 25, mu is 0.3, sigma YT is 220. We can find out Fs, only Fs is unknown. So factor of safety is 2.00. Okay, now let us go to last theory, that is maximum shear strain energy theory, or it is also known as the distortion energy theory or von Mises theory. Okay. Then what is the equation for this theory? Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to sigma permissible square. Okay. Everything is known to you. Sigma 1 is known to you. Sigma 2 is known to you. What is sigma permissible? Sigma YT upon factor of safety. Okay. You find out factor of safety, that is 1.92. Okay. So like this, designer can determine factor of safety by based on any theory. Okay. Now, let us go to problem number 3. This problem I have taken from Ramamrutham, strength of material by Ramamrutham. A shaft 120 mm in diameter is subjected to a bending moment 12 kilonewton meter and a twisting moment 18 kilonewton meter at a cross section. Okay, at a cross section of the shaft. So, bending moment is given, twisting moment is given. Okay, that's why it is a combined stresses. Find the maximum direct stress induced for the section. Means what? It is sigma 1. Okay, maximum direct stress. And the plane on which it acts, that is theta p, plane of principal plane. Principal stress, plane of principal stress. Take mu is equal to 0.25. Find also what stress acting alone will produce the same maximum strain, and secondly, the same maximum strain energy per unit volume. Okay, this we will discuss later. First, we will find out maximum direct stress. That is nothing but the sigma 1. Okay, it's a normal stress. Normal maximum stress means sigma 1. Okay, so this is the given data. D is equal to 120 mm diameter of the shaft. Then bending moment 12 into 10 raised to 6 Newton meter. Okay, what was given here? 12 into 12 kilonewton meter. So 10 raised to 3 for kilo and 10 raised to 3 from converting meter to mm. So like this, it is 12 into 10 raised to 6 Newton mm. Okay. Similarly, torque is 18 into 10 raised to 6 Newton mm. Okay. We have to find out sigma 1 and sigma 2. And also theta p, that is angle of principal stress. Okay. Then this also we have to find out what is the equivalent. What they have mentioned here, the stress acting alone. Okay, that means if there are no combined stresses, if only one kind of stress only acting as if on that in that shaft, then what will be the maximum value according to that? Means what? Sigma equivalent for strain for the same maximum strain. So which theory it is expected here? Maximum principal strain theory. Here for the second part we have to find out same maximum strain energy per unit volume. Means is sigma equivalent for same maximum strain energy per unit volume, means we have to use maximum strain energy theory to find out sigma equivalent. Okay, so let us first find out sigma 1 and sigma 2. Okay, so according to first let us find out this first one. Okay, that means sigma 1 and sigma 2. Now this is the formula. Whenever we know bending moment and torque, how to find out principal stresses? This is the formula. Sigma 1 and sigma 2 is equal to 16 upon pi d cube into bracket m plus or minus square root of m square plus t square. Now how this formula has come? Okay, that I have given it at the end of the problem. Okay, so that we will discuss there. Okay, right now just assume that this is the formula. Okay, so d is the diameter of the shaft, m is the bending moment, t is the twisting moment. Okay, so simply we have to put the values. D we know, m we know, t also we know. Okay, so we can find out sigma 1 and sigma 2. Okay, so 16 upon pi d cube, that is 120 cube. M is what? 12 into 10 raised to 6 plus or minus square root of m square, that is 12 into 10 raised to 6 bracket square plus 18 into 10 raised to 6 bracket square. Okay, so how to simplify it? This is equal to say 16 upon pi into 120. This will become 120 cube. This will become 2.947. Okay, into 10 raised to minus 6. Okay, now what is in the bracket? 12 into 10 raised to 6 as it is, plus or minus Here 10 raised to 6 bracket square plus 10 raised to 6 bracket square, we have taken common and we have taken out of the square root sign, it will become 10 raised to 6. Okay. So square root of square means 10 raised to 6 into what is remaining, 12 square plus 18 square root of that one. So that will come 21.633. Okay. So this 10 raised to 6 will be cancelled with this and this. Okay. So what is remaining? Sigma 1 and sigma 2 is equal to 2.947 into bracket 12 plus or minus 21.633. So sigma 1 is equal to addition, that is 99.21 Newton per mm square. Sigma 2 is equal to minus, that is minus 28.37, because this value is greater, Newton per mm square. Okay, so we have found out sigma 1 and sigma 2. This is only asked direct maximum direct shear, maximum direct stress means sigma 1 and sigma 2. Okay. Now we have to find out angle of principal plane. Okay. So for the position of principal plane carrying the maximum direct stress, that is maximum principal stress, we can use this formula. Okay. Tan 2 theta P1 is equal to twisting moment upon bending moment, T upon M. Okay. That is 18 upon 12 is equal to 1.5. Therefore, theta P1 is equal to 21.15 degree. Here we can also find out this theta P1 from the formula, this one, which see in the recap we have seen theta P1 is equal to tan 2 theta P1 is equal to, where is that one? Okay, this one, tan 2 theta P is equal to 2 tau xy upon sigma s minus sigma y. Okay, but as the bending moment, bending moment and torsional moment both are given, usually instead of using the stresses, we can use the moments to find out the principal, angle of principal plane. Okay, so let us go further. This is problem number 3, no? Okay, so we were here. We have found out theta P1. Okay, 28.15. Theta P2 is 28.15 plus 90 degree. Okay, then we have to find out second part, as I told you, to find equivalent stress using maximum principal strain theory. Okay, that is principal strain. According to maximum principal strain theory, what is your equation? Sigma 1 minus mu sigma 2 is equal to sigma permissible. Okay, so here this sigma permissible will denote equivalent stress, this one, or the stress which is acting alone. So sigma 1 minus mu sigma 2, this is for complex system and this is for simple tension test, means only one kind of stress is acting. Okay, so that means we have to find out equivalent stress of this complex system for simple system. Okay, so here sigma permissible means we will simply call it as a sigma equivalent. So sigma equivalent is equal to, that is nothing but sigma permissible, that is equal to sigma 1 minus mu sigma 2. We have found out sigma 1 already, mu is directly given, sigma 2 we have calculated. So sigma equivalent, that is equivalent stress. Okay, if it is only one kind of stress, that will be 106.23 Newton per mm square. Okay, similarly, if it would have been the alone stress, single stress, that means one kind of stress, that is equivalent stress using maximum strain energy theory. Okay, so what's the equation for maximum strain energy theory? Sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. Now here, this is the strain energy representing complex stress system, and this is the strain energy representing simple tension test system. Okay, so this is only one kind of stress, this is both combined stress. So here sigma permissible means sigma equivalent. Okay, so sigma equivalent is equal to, that is nothing but sigma permissible is equal to, we have to take square root of this one because this is square. Okay, square root of this formula. So now you have to just put the value, put sigma 1, put sigma 2, mu, you get sigma equivalent is equal to 109.69 Newton per mm square. Understood? Okay. Now, as I told you, how this equation has come. This one. Okay. So we have used this equation sigma 1, sigma 2 is equal to 16 upon pi d cube into bracket m plus or minus square root of m square plus t square. Okay. This actually you have learned in strength or in unit number 4, I think, torque, and unit number 2, that is bending moment. Okay, but separately you have learned. In bending moment you might have learned in unit number 2 or 3, and torsional moment you have learned in unit number 4. Now here we have to combine it. The shaft is subjected to bending moment also and torsional moment also. Okay, so how to calculate this one? So from here, so first consider the bending equation. Okay, so you have learned this in unit number 2. M upon I is equal to sigma b upon y, where m is the bending moment. Okay, I is moment of inertia, that is area moment of inertia. Sigma b is bending stress. Y is the distance of neutral axis. Okay, or the distance of cross section from neutral axis. Okay, from this one you can write down equation for sigma b. Okay, sigma b is equal to m upon I by y. Okay, and you know this is either in acting in x direction or y direction, so we call it as a in x direction, suppose. So sigma b is nothing but sigma x, that is m upon I upon y. What is I upon y? Do you remember? This is section modulus. Okay, m by z. Okay, so m upon what is z? Section modulus. Okay, so it is given by pi by 32 d cube. Okay, so this will become 32 m upon pi d cube. Correct? What is it? Sigma b. We are calling it as a sigma x. Okay, so sigma x is equal to 32 m upon pi d cube. Okay, and what is sigma y? It is 0 because there is no stress along y direction. There is stress only along x direction. This is the bending. So all the stresses are along the x direction if x is the horizontal. Okay, then let us consider the torsional equation. Again, this is the basic equation. T upon J is equal to tau upon R, where T is the torsional moment, J is polar moment of inertia, tau is shear stress, and R is radius of the shaft. Okay, so from this equation, we write down tau is equal to T upon J upon R. For this tau, we call it here tau xy. Okay, so what is J here? Polar moment of inertia is given by pi by 32 d4. Okay, and what is R? It's a radius of the shaft. Okay, for maximum stress, it is at the end, at the surface of the shaft, that is d by 2. Okay, so pi by 32 d4 upon d by 2, it is pi by 16 t cube. So tau xy is equal to 16 t cube upon pi d cube. Understood? Now, knowing above values, we know tau xy is this one and sigma x is this one, sigma y is 0. Okay, so what we do? We know this formula, principal stresses sigma 1 and sigma 2 is equal to sigma x plus sigma y by 2 plus or minus square root of this one. So put the value of sigma x, sigma y and tau xy. Okay, so what is sigma x plus sigma y is 0 only. So it is sigma x by 2, that is 32 m upon 2 pi d cube, plus or minus, put here sigma x by 2 because sigma y is 0. Again, this is square, plus put the value of tau xy, that is 16 t upon pi d cube bracket square. Okay, now how to simplify it? So this is 32 by 2, it will become 16 m upon pi d cube plus or minus square root of, here also 32 upon 2, it will become 16 m upon pi d cube bracket square plus 16 t upon pi d cube bracket square. Okay, so what you can take common? 16 upon pi d cube bracket square plus 16 upon pi d cube bracket square. Okay, you can take this common. So what is remaining inside the square root? M square plus t square. When you take common 16 upon pi d cube, so it is square root of square. So it will come out of the square root, that is 16 upon pi d cube. Now you can take from these two terms, what you can take common? 16 upon pi d cube, 16 upon pi d cube. So sigma 1 and sigma 2 is equal to 16 upon pi d cube into bracket this m as it is plus or minus square root of m square plus t square. Understood? So you have to use this formula directly. whenever shaft is subjected to bending moment as well as torsional moment. Okay. Now let us go to problem number 4. Okay. A solid shaft is subjected to a bending moment of 300 Newton meter and a twisting moment of 225 Newton meter. Okay, so bending moment is given, torque is given. Find the diameter of the shaft with a factor of safety 2 according to maximum principal strain theory. Take yield point strength as 210 Newton per mm square and mu is equal to 0.25. This is also the problem from Ramamrutam. Okay. Now see here specifically they have asked to use maximum principal strain theory only. So don't find out diameter by using all theories. You have to always read the problem, see what is asked, what is given, and accordingly only you have to solve the problem. Okay. So what is the given data? Bending moment M 300 into 10 raised to 3 Newton mm. We have converted meter to mm. Okay. Then torque 225 into 10 raised to 3 Newton mm. Then factor of safety is 2. Yield point strength is given 210 Newton per mm square. Mu is given 0.25. We have to find out D. That is diameter of the shaft according to maximum principal strain theory. Okay. So what is the statement of maximum principal strain theory? According to maximum principal strain theory, failure takes place when the maximum principal strain in the complex stress system reaches the value of maximum strain in the elastic limit in the simple tension test. Okay. So mathematically, sigma 1 minus mu sigma 2 is equal to sigma permissible. Okay. So how to find out principal stresses sigma 1 and sigma 2? By knowing M and T. Already we have derived this formula. Sigma 1 and sigma 2 is equal to 16 upon pi d cube into bracket M plus or minus square root of M square plus T square. Okay. So what is D is unknown. D we have to find out. Okay. So keep D cube as it is. Put the value of M, that is 300 into 10 raised to 3. Put the value of M and T here. Okay. How to simplify? This is 16 into 10 raised to 3 upon pi d cube. Okay. This one. Then this 300, this 10 raised to 3 we have taken common. Here it is 10 raised to 3 and here it is 10 raised to 3 square plus 10 raised to 3 square. It will come out of square root, that is 10 raised to 3. So we have taken 10 raised to 3 and 10 raised to 3 common here. Okay. Then what is remaining inside the bracket? 300 plus or minus 300 square plus 200 square. Okay. So that means now the calculation of this one 16 into 10 raised to 3 upon pi, it is 5092.96 upon d cube into bracket. This is 300 and this value is 375. So addition will be for sigma 1, that is sigma 1 is equal to 3.44 into 10 raised to 6 upon d cube, and sigma 2 is equal to minus, because this is greater, no? So minus 0.38 into 10 raised to 6 upon d cube. So this is tensile in nature, this is compressive in nature. Okay. Once we find out sigma 1 and sigma 2, let us calculate permissible stress. Okay, that is permissible normal stress. Sigma permissible is equal to sigma yt upon fs, that is yield point strength upon factor of safety. So 210 upon 2, sigma permissible is 105 Newton per mm square. Okay. So what is your equation for this theory? Sigma 1 minus mu sigma 2 is equal to sigma permissible. Put all the values. Everything is in diameter d. D is unknown. So sigma 1 is this one. Okay. Mu is 0.25. Sigma 2 is this one, which is minus. So minus minus will become plus here. E is equal to, what is sigma permissible? 105. Okay. So d cube you have to find out. So take d cube here and take 105 here. And simply you just add it. You will get diameter is 32.28 mm. Okay. Now let us go to last problem. Problem number 5. That is also taken from Ramamrutam. Okay. A solid shaft is subjected to a bending moment of 3000 Newton meter and a twisting moment of 9000 Newton meter. Find the diameter of the shaft to satisfy the condition that the strain energy stored per unit volume under a pure shear stress of 30 Newton per mm square. Take E is equal to 2 into 10 raised to 5 Newton per mm square and mu is equal to 0.25. Okay. See, what is the meaning of this one? What is given? See, bending moment is given 3000 Newton meter. So 3 into 10 raised to 3 into 10 raised to 3 mm. Okay, so 3 into 10 raised to 6 Newton mm. T is 9 into 10 raised to 6 Newton mm. Now, this somewhat here you may not understand the wording. Okay, what is the notation for this 30 Newton per mm square? Okay, read the statement again. Find the diameter of the shaft to satisfy the condition that the strain energy stored per unit volume under a pure shear stress of 30 Newton per mm square. See, in theories of elastic failure, there are always two systems. One is simple tension test, that is simple stress system. Other is a complex stress system, that is your actual mechanical component or actual system, complex stress system. Okay. Now here it is given that pure shear means there is only one type of stress, that is shear stress, that is 30 Newton per mm square. So this is nothing but the tau permissible. So this is the stress which is a shear stress which you have found out from a simple tension test. Okay. So that means sigma permissible is given as 30 Newton per mm square. Okay. We have to find out diameter according to maximum strain energy theory. Okay. So what is the statement of mathematical statement of strain energy theory of failure? Sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. Okay, so now we have to find out sigma 1 and sigma 2, which will be in terms of diameter d. D is unknown. Okay, and sigma permissible is already known to you. From you can find out sigma permissible from tau permissible. What's the relation? As I told you in the earlier problem, shear stress, permissible shear stress is always half of the permissible normal stress. That is that is a tensile stress. Okay. So as tau permissible is 30, what will be the value of sigma permissible? Double of this one, that is 60 Newton per mm square. So this is known to you. Now we have to find out sigma 1 and sigma 2 in terms of diameter d, so that when we put here, you will get the value of d. Okay. So how to find out principal stresses? By knowing bending moment and torsional moment, sigma 1 and sigma 2 is equal to 16 upon pi d cube into bracket m plus or minus square root of m square plus t square. Okay. So this is d is unknown. What is m? 3 into 10 raised to 6. Put the value of m and t here also. Okay. How to simplify? Okay. 16, this 10 raised to 6 is common in this term and in this term also. 10 raised to 6 bracket square plus 10 raised to 6 bracket square, you can take common and out of square root, that will become 10 raised to 6. So you can take this 10 raised to 6 common here and you can write down 16 into 10 raised to 6 upon pi d cube. So what is remaining in the bracket? These 3 plus or minus 3 square plus 9 square. Okay, so that means 3 plus or minus 9.49. Okay, so addition will give you sigma 1. 63.59 into 10 raised to 6 upon d cube, and subtraction will give you sigma 2, which will be minus because this value is greater, minus 33.05 into 10 raised to 6 d cube. Okay, so now what you will find out? Permissible normal stress. Okay, so permissible stress, sigma permissible is calculated from the given permissible shear stress. So sigma permissible is equal to tau into 2 into tau permissible, that is 2 into 30, that is 60 Newton per mm square. Okay, this relation is true for all the material, that usually shear stress, permissible shear stress, or the stress which is to be found out from simple tension test is half of the normal stress, permissible normal stress. Okay, so putting the value of sigma 1, sigma 2 and sigma permissible in this equation of theory. Okay, so put the value of sigma 1, put the value of sigma 2. Now this minus will become plus because sigma 2 is minus. So 2 into 0.25 into this sigma 1 into sigma 2 is equal to sigma permissible square, that is 60 square. Okay. Now how to simplify? See, 10 raised to 6, 10 raised to 6 into 2, 10 raised to 6 into 2. Okay. And here 10 raised to 6 into 10 raised to 6, that is 10 raised to 6 raised to 2. It will be common. So that is 10 raised to 12. Understood? And what again, which term will be common? D raised to 6, because this is D3 square plus D3 square. Here is D3 into D3, d raised to 6. So you can take common from all the terms 10 raised to 12 upon d raised to 6. Okay. Now what is remaining in the bracket? 63.59 square plus 33.05 bracket square. Okay, because this will be square, so that will minus will become plus. Plus 2 into 0.25 into 63.59 into 33.05. Okay, is equal to 60 square means 3600. Okay, so this d raised to 6 you take here because we want to find out the value of d, and this 3600 put here. Okay, so simplify this one, you will get diameter is equal to 109.43. Okay, understood? So I hope you have understood all the problem. Now what is the homework for you? Okay, there are still many problems are given in the Ramamrutham, in Bhavikatti, in Ratan, or if you have any local publication book, I don't mind solving problem from local publication book, but use these notations only, because there are different notations in local publications book, different method also sometimes. Okay, so please try to understand the problem and solve all these 5 problem in your notebook. Otherwise, right now you may have understood the problem solution, but when you solve it, you may not be able to solve it completely. Okay, so first you solve all these 5 problem in your notebook, then at least solve 2 unsolved or 2 solved problem from any book. Okay, then and then only your problems or numericals on theories of elastic failure will be perfect. Okay, so if you have any doubt on this one, you can dial me at any time. Okay, so thank you very much.